Welcome. Uh, Welcome to chapter 5, second lecture on lightning. Last time, in the first lecture, that is, I explained how the lightning strike takes place from the clouds. And I did mention about the that in the world, yeah, in the world, at any given time, something like 50 lightning phenomenon is taking place every second. This is the picture taken by a satellite. As you can see, it is covering Australia and India and the Middle East. And as I also mentioned, that the lightning activity is highest in the equator region. And the middle line here in blue gives you also tells you the equator region, and you see all blue patches on the on this figure or on this photograph are showing the lightning activities. This is there is a continuous process of recording this activity with the help of satellites. So you can anytime go to this and see it yourself also. So these are, yeah, we explained mechanism of lightning strike, the beautiful picture at the Grand Canyon, and how does it, yeah, how how does the lightning propagates from the clouds downwards. This takes only few milliseconds to come and strike. The bright light will come, and that is the instant when it strikes. As you can see, it is propagating, and that was the lightning strike. And then we also learned about the upward moving lightning. I'll skip that here. You see the upward moving lightning very clearly seen, and the downward moving meet together and the lightning strikes. Yeah, I did mention about where does it prefer to strike. All metallic objects, the sharper is the metallic object, preferable it is for the lightning to strike upon. All tall structures and the buildings, for example, Empire State Building was prone to lightning for a very, very long time because it was the highest building on the globe. Today, the Burj Khalifa in Dubai is the highest building, and the number of lightning strikes on Burj Khalifa is phenomenal. Obviously, all these buildings are protected from lightning. From They are protected to provide a good least resistance path for the lightning current to go to the ground. That is how it is. The lightning conductor. The lightning also prefers individuals carrying, for example, an umbrella. The umbrella stick is mainly of metal and it is pointed at the top. You will be amazed to learn that lightning also prefers on cell phones. Cell phones also have an antenna, inbuilt antenna. Earlier, the external antenna used to be there, and the antenna, especially when the cell phone is active, is connected through some signal, and lightning, it has been observed by that number of people talking on the cell phone have been hit by lightning strikes. So never switch on your cell phone when the thunder is just above you. So lightning strikes on the trees when no metal around is available. Lightning strikes on the top side of the highest point on the trees. Also, we'll see how does it make damage. And lightning strikes on any metallic object. Let it be only simple water pipes on the top of the building, or some sharp points antenna on the top of the building. Lightning prefers to strike on that. So you know why does it happen? Because the metallic objects on the ground also get induced voltage, and some breakdown phenomenon begins at the tip of the metallic electrodes. And the most wide metal spread over the earth is the transmission lines. And we have learned when it we have learned in overvoltage transient chapter how when the lightning strike, the overvoltages are produced by lightning strike on the power systems. Excuse me. So there is tremendous loss of life because of lightning strikes. Loss of strikes maybe when the lightning strikes on individuals, or when the lightning strikes on a collective, when people get collected at some spot and the lightning strikes there. One US statistics says that out of about 300 people struck by lightning, 100 are killed each year in USA. The figure in India is much higher, very much higher. A large number of people, estimated to be 60% of deaths, sustain injuries but survive, as the statistics say. Yeah, it can happen that when the lightning strikes you, you may be able to survive, but it does damage your organs. It does cause injuries like burning your skin, burning your hair. And if it is reaching, it can even affect your heart. It can affect your brain. That is an electric shock, like an electric shock. The chances of survival after getting struck by lightning is much lower in India as compared to the advanced countries. But more people get affected by lightning. I mean to say, more people get struck by lightning in our country. The reason is that the density of population in our country is much higher. Lightning protection is not provided everywhere. And more percentage of people get killed by lightning. The reason again is the awareness about lightning. If the general people are aware of the effects of lightning, it is possible that they may survive even after getting struck by lightning. For example, Sometimes the um, when the lightning strikes on a person, uh, he's dead for initially, but he can be revived. His respiration system can be revived if, for example, mouth to mouth air feeding is respiration is given. There's so many other methods. If the first aid reaches the person quickly struck by lightning, then there's more chance, and the people abroad are well trained about it, and they that is why the percentage of survival is much higher in advanced countries. You see here a figure. This person is struck by lightning. One photograph at the back and another one on the arm. What do you observe? Is very typical uh, burnt. This reddish portion, what you see here, is the skin burnt, but the skin has burnt in a very typical fashion. And what does it remind you? It does remind you the streamer corona pattern. Streamer corona on in the liquid dielectrics we'll see later is exactly like this. Streamer corona in gaseous dielectrics may be slightly different, but in liquid dielectrics looks like exactly like this. So this is one of the kind of injuries which is external, may not be internal injuries are there in this particular case. So what yeah, when the lightning causes a lot of fire hazards. How does it cause fire? For example, if the lightning strikes during the dry season in jungles, it ignites fire. Why does it ignite fire? The lightning always attacks insulation, electrical insulation. You can imagine if the lightning strikes on conductors, the current finds its least resistance path and travel over the conductor. But when the lightning strikes on insulating materials, the phenomenon is different. Insulating materials have got hundreds and thousands of mega ohm resistance. The resistance, ohmic resistance, if you calculate, if you measure, yeah, you can measure also. The ohmic resistance is of the order of hundreds and thousands of mega ohms. So when the very high intensity of current is injected there on the insulating material, it is not able to travel to the conductors. Very high I square R loss takes place, and that generates heat, and that can ignite fire. As you can read it here, the lightning strike may inject anything between a few two hundreds of kiloamperes. Even 200 kiloampere magnitude of impulse current obviously has been recorded, and in some cases it may be a few kiloamperes only the current involved, but it is all very short duration in milliseconds, and all insulating materials are prone to fire. Let it be tree, let it be woods, mostly it is wood, and we will learn when it attacks the air, it doesn't ignite any fire, but it expands the air. We'll learn about it. The sudden generation of heat ignites fire in insulating material. What do you see here in this photograph? This is a pine tree, and the pine oil is also taken for igniting fire at home because it is vulnerable, because it is very highly inflammable. And when lightning strike took place on a pine tree on the top of obviously it will take place at the top of the tree. The tree has fallen, and when it has fallen, you can see here that the outer shell of the wood is intact, whereas inside the tree it has charred. It is wood coal is formed. How could it form? And why did the outer shell not burn? Only the inner did burn. The reason you can understand. The current always tries to flow through the least resistance path. The inner of the core of the stem of the tree would always contain more of moisture as the outer shell. The outer layer of wood is dried, so the lower resistance path is inside the tree, and the lightning current injected does not find passage to the ground, so it burns the inner portion of the tree. Like this process is actually done by human being in making wood coal. The wood is burnt under the condition of least availability of oxygen. So this is what has happened here. The inside of the tree has charred, wood coal is formed, outer shell of the tree having a higher insulation resistance has remained intact. The current has not flown over the outer shell. It has flown only through the inner shell. It is a very interesting phenomenon. It takes place, but for some it may not be. People may not notice that this kind of a thing happens. Now another incident. I have examined a number of incidents where blast has been created by lightning. How does blast takes place in case of lightning? The lightning is known to be attracted to strike on sharp metallic objects, terminating in free air. For example, rods, tin sheds, and pipes. The edges of the tin shed are sharp points. The field intensities there is very high. And construction in the construction, you may come across such kind of metallic objects. Consider such an object projected on the terrace of a house, of a concrete building. For example, water pipe. Water pipe is brought to the top of the house. If it terminates within the building. Suppose the water pipe is brought on the top of the house and the lightning strikes on the water pipe, and that water pipe outlet, I mean, not that very water pipe, the outlet of the tank would terminate somewhere in the building inside, bringing water to the kitchen, water to the toilets, and terminate there. And the lightning strike current reaches the outlet of the uh, uh, outlet of the storage tank, outlet pipe of the storage tank. It goes inside the building. I mean, the current or the charge travels inside the building, where there is a termination of the metallic pipe. Now the charge is stuck inside the building. What will happen? The charge will uh, remain in the building for a while and try to find passage to go to the ground, because it always tries to find the passage to go towards the ground, the least resistance path. But it is, in this case, it is stuck inside the building. Then it flows more of charge on the uh, floor and walls, not inside the walls. Why? Because the resistance, volume resistance, is always higher than the surface resistance. Surface resistance being lower, the charge remains on the surface. That means on the surface of the walls, on the surface of the floor, and wherever any insulating material comes in the passage, its chairs, that is burnt in the on its way, and then it always tries to get it is attracted towards conductive portion of the, conductive, that is metal availability inside the house. For example, a lane. For example, a lane at the leg of a table. Sometimes it happens that there is a dining table and there is it is resting on insulated uh, 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 at the tip of the leg, but the insulation has gone, weared out, and the metal screw is still there, and the leg of the dining table is resting on the metal screw. There are often nails on the walls, so the charge gets attracted towards the metal portion on the surface, on the floor, or on the walls. And after getting attracted there, where should the charge go? It needs to be consumed. It is injected through this metal, small metal, it may be metallic object, into the air. And when it injects, the charge injects into the air is insulating, find it. It expands the air with the heat produced at the tip of the metal because of the high density of charge coming out of the metal portion. It expands the air and it causes a blast, an explosion without explosive. This kind of you can read about it more in detail. Even some of the specifications have written one of the bad effects of lightning. And so when it expands inside the room, it is something like thunder happening inside the room. I explained thunder, when the lightning between the two clouds takes place, it is the leader channel between the two clouds taking place there, and the temperature in the core of the leader channel may rise to the tune of 30,000 Kelvin, and that high temperature in the core of leader expands air. So you hear the thunder sound from the clouds, and the thunder sound is rebound echo like condition does happen. That is happening kilometers away from you, and when this thing happens within your house, you can imagine it's a blast. I have seen the kind of destruction caused like this. uh, I have investigated the case when a thermal power station chimney at Balco thermal power station was under construction, and the lightning struck on the top of the uh, uh, chimney under construction, and the metallic portion of the chimney was not grounded. I mean, the reinforced uh, steel uh, uh, was not continuous to the ground. There is always RCC, reinforced cement concrete. So steel reinforced cement concrete. The steel was not continuous to the ground, so the charge injected on the steel reinforcement of the chimney gets stuck somewhere in the middle of the height of the constructed chimney. And then where should it go? What should it do? It has created a blast, as I explained, and the chimney shattered, and number of even deaths have taken place in under such conditions. So blast created by lightning is also a common factor which may not be known to everybody. Yeah, one such episode uh, in Himachal Pradesh, where from I am speaking from IIT Mandi. There is a temple in Kulu Valley, or not in the valley, uh, on the hills above the Kulu Valley, where Beas River flows. And that temple is known as Bijlee Mahadev. Bijlee is nothing but electricity, and Mahadev is the Shiv, the god Shiv, and it is known as this temple is Shiv temple, but it has been given name Bijlee Mahadev. What is the reason of this name to have been given to this temple? A lot of people with devotion come there, that the Shiv has got the lightning bolt is the symbol of weapon, you can say, for the Shiv to take care of the bad elements. Every time the lightning strikes on this temple, you see, every time the lightning strikes on this temple, a blast is created inside the temple, in the same way as I explained. Why does it strike there? There is a very typical construction of, no, sorry, I don't have it here. Very typical construction of traditional construction in Himachal Pradesh, which consists of only stone and wood, log wood. In between the wood log is placed, and then the stone, even the roof is made out of stone. The only part in the only part which has metal is that when the two slopes of the roof meet together, where they meet together at the highest point of the building. The that is covered with thin uh, metallic tin, you can see, and that tin, to prevent water to go inside the building, that small portion is covered with a V-shaped tin, and that tin is not grounded. It is also floating. There is no ground available nearby. So the as I mentioned, lightning prefers to strike on the metals, and the only metal in the building is the topmost portion of the ceiling. From outside, if you see V-shaped tin is there, and it strikes, the lightning strikes on that tin, and then lightning, since it does not find passage to go inside the ground, the lightning charge charge injected by lightning circulates on the walls and the floor of the building inside, everywhere, all around. And whatever charge is able to go inside the temple, again it tries to find out the metal, and near the uh, near the shivling, which is made of soft stone, there is some metal available in the form of, for uh, uh, for uh, performing the or for the worship of the deity. There may be a water uh, water pot. There may be a pot for burning the uh, oil, that is we say diya, and some metal is around nearby. uh, the shivling, that is the deity made of soft stone, is available. It gets attracted, the charge gets attracted towards the metal near the deity, and then where should the charge go? The charge which has been circulating on the walls and floors of the temple, after getting attracted towards the small metal object placed for worship near the deity, where should it go then? The charge from the metal is injected into the atmosphere, and the expansion of air takes place, and again, as I explained, a blast takes place which affects the nearby deity. Because the deity is made out of soft stone, it gets shattered. Now, the that is a when the lightning strikes and the whole process of shattering of the deity takes place, it is still considered by some to be a good omen. And now the religious people, they don't want to uh, put a new deity over there. What do? They assemble the stones, and they want to put them together. In order to put them together, since it is going on for hundreds of years, they don't get, there's no adhesive available as you have in modern times. So traditionally, they have been putting it together with butter and a flour, a typical flour called sattu. When they mix it together, the deity looks like, as you see on the left side, the assembled deity looks like this. It is worshipped by the people, by the priests there, people who come from long distance every day, and it's a very important tourist spot. But people did not understand uh, why does it shatter. I have tried to explain it to you. Every time the lightning strikes there, the deity shatters because no earthing has been provided nearby. Even there is a mast, tall mast about 60 feet high, but that mast is also made out of wood. So the lightning prefers to strike on this small tin tin shed on the top of the roof of the building, the metal. Yeah, one thing I would like to tell you, I did mention that lightning strikes, for example, on umbrella. There are episodes when uh, in a in a stadium where some function is going on and there are 60,000 people and there is thunder above and one girl gets struck by lightning out of 60,000 people. The clue, later people found out that the girl had just finished a, a conversation on her cell phone. The girl was dead for a few minutes, but the uh, protective forces, uh, organizers reached quickly and could revive the girl. And she told every what exactly happened with her. She only got some burnt portion where she was having metal on her body, for example, metal ring, uh, or yeah, that was wherever she had metal on her body. This thing took place somewhere in 1999 when the cell phones had just been introduced in the United States. This happened in Washington D.C. in the United States in somewhere in 1999. Then there have been more people who have got struck by lightning, uh, talking on the phone. There is an incident explained in Reader's Digest when a girl hiking alone through the jungles, after the rain, she suddenly gets struck by lightning, and the lightning strikes where? At the back, she had a rucksack, and the rucksack had a metallic frame. The lightning struck on the metallic frame so that her upper part of the body was saved because found the lightning found a conductive path, but the lower portion was uh, burnt and paralyzed for a while severely. So such cases are there which prove that lightning does attract is attracted by metals and of course signals also, you could say electromagnetic signals also. So what should you do for protecting yourself from lightning? The only way for the human being to get to protect is whenever there is thunder, one should go indoors. One should not remain outdoors and never open your cell phone and don't take refuge under a tree because the tree is a tall structure. Sometimes it has happened, number of people have taken refuge under the tree and get got stuck by lightning and number of deaths together have taken place. It's a Lightning is a very peculiar phenomenon, and every lightning strike is unique and peculiar in its nature. If hit by direct lightning strike, usually only a miracle can make the living being survive. Very difficult to survive. But I told you some stories when people did survive, but only in advanced countries something like 60%, but in our country very few people are able to survive. The high potential difference across the body caused by lightning strike of a living being causes injection of current inside the body. The high potential, because of the high potential developed, there is some current which is flowing through the body. It can lead to ventricular, what do you call it to be, fibrillation, that is unsynchronized muscle operation of the heart. That is some kind of a paralysis taking in the muscle paralysis taking place, and if it reaches the heart, you can imagine if the heart is no more functioning, it can cause death. It can cause respiratory arrest and neurological damage, or even total burning of the body also takes place. So this is the effect. Uh, this is the effect what you realize when these are the effects when lightning strikes on the human being. And the recommendation for human safety measures is when a thunder roars, go indoors. One should teach even the children the small sentence, when the thunder roars, go indoors. Don't let the lightning strike you directly. When in open, one should never take shelter under a tree, as I mentioned, in thundery conditions. Any metallic object carried by a person in open attracts lightning. For example, a cell phone or an umbrella, all these things do attract lightning. Caught by thunder in the wide open, the best would be to sit on the ground with the 2 feet close to each other. Why your feet close to each other? Because the potential difference across the body is not found in this way. When you sit with your feet together, there is no gap between them, so the potential difference is not formed, and that potential difference, if formed, that is across the body. Then sit in a bog down and ears covered with hands also. Why? So that you don't get affected by the loud sounds produced. This is when you cannot get away indoors under the thundery conditions. Don't rush towards a tree. Sit on the main ground, let yourself get wet, and sit in such a position that the lightning doesn't hit you. If caught in a vehicle by lightning strike, it is advisable to remain inside and not touch the metal body, because a vehicle behaves like a Faraday cage, and over the tires it may be carrying some potential. So if you come out not taking care and touch the metallic body, the whole potential will discharge through your body, and that can cause severe damage. When there is an active thunder, it would be advisable not to bathe in open water also, because water has got more conductivity than the soil. So water does attract lightning to strike. So don't be in the water. It is advisable not to be in the water. Then this is for individual safety. These are the measures for individual safety. Okay. Yeah. Yeah, when we talk about the protection of buildings and structures, the best, there are a number of protection devices, protective devices developed over the time. Some devices are very expensive, not possible to be put by individual houses. They may do good in case of very big buildings and all. But there also, what I feel, a air termination network, that is the protection of the building by lightning conductor. The lightning conductor will have air termination network. That is the sharp point, as you see the vertical terminal of the building. This is the air termination network. And the ceiling or the roof of the building in dark lines, as you see it here, there is metal strip connected at the edges, because it is the edges of the building making sharp edge because of the sharpness which attract lightning to strike. So all the edges are covered with a continuous metal strip connected to the air terminal, and ultimately with the help of down conductor, this is brought to the ground. With the help of down conductor of the lightning conductor network, it is brought to the ground. If you do this kind of an arrangement, if the ceiling of the house is not slanted, it is flat, all uh, all along the parapet one should put the metal strip. This is all given in the specifications how to safeguard the buildings. This is all available, and one should make the protection. The down conductor is defined as the conductor connecting the air terminal to the earth electrode. It suggests copper, aluminium, and their alloys, or even galvanized steel. In our country, it was uh, followed by copper, but some problems arose. So people have taken even aluminium or galvanized steel. But the main thing is it should be continuous. It should not have at the joints high resistance. Earth termination system, earthing, separate earthing should be done as compared to the neutral earthing. Neutral earthing, which is done only at the substations, it should not be mixed with the lightning earthing. It can be done with the household, simple household earthing for protective system within the house. We have learned the you can say fifth wire of the three-phase five-wire system, that is grounded or earth separately, and the earthing wire, the earth termination of the lightning conductor can also be connected to that. Combined resistance to earth of the whole lightning protective system should not exceed more than 10 ohms. That is the specification I've tried to explain it to you. Yeah, let's talk just one more point for today, that uh, you have seen the transmission lines put on the top of the transmission line, and similar kind of protection is also needed sometimes. For example, soft tanks, I mean the had yeah, petroleum product tanks, etc., where they need to be protected. There is a zone under. They are protected with ground wire put on the mast, or just the ground wire on the mast. No wire. Any ground mast, as you see it here in the figures here, uh, the protective zone under the mast makes an angle. This is the lightning conductor mast. This is the lightning conductor mast. This is here. This is here. And there are two, uh, you can say, philosophy for the lightning protection zone. With an angle of 30 degrees, as you can see it here, everything falling at an angle of 30 degrees, that means a cone built at the top point having 30 degrees of angle, that is known as stringent protection. And other which is not that stringent, everything falling at 45 degrees is not that stringent. That stringent protection is to be provided to those items which are crucial. Otherwise, not that crucial. 45 angle protection philosophy or can also be taken, because all this has been verified by experimental investigations, and they say, I mean, people have found there may be some possibility when you take the angle 45 that the objects within that cone may get struck by lightning, but if you take that angle 30, nothing will get struck by lightning. So we um, stop our uh, lecture today here. We'll see you in the next lecture. Thank you very much. चलो अच्छा हो गया, ये नया टॉपिक आ जाएगा नेक्स्ट।